Welcome to Just Another Solar Podcast with Luke Beattie, that's me, and Karl Jensen from the perspective of the Australian solar industry. G'day, Karl. How are you?
I'm good, Luke. I'm good. Some great feedback over the last couple of weeks about our previous podcast, Luke.
Yeah, it's been good. I was stoked to hear a shout out from Nigel Morris on the Solar Insiders program, because that's top of the tree as far as Australian solar podcasts go, and also great solar business podcast. I listened to the latest one, and it was Nigel with Lindsay Hart from Selectronic.
Yep.
And they were talking about 35 years plus in the industry. So last time we introduced ourselves as 10-year plus veterans, but maybe not compared to these guys.
Indeed. But there are a lot more people employed in the industry now than there were a couple of years ago, where we're still growing at an amazing rate. And I think we're tracking around the 800,000 panels being installed nationally a month, which is a big number.
That's huge.
So, if we work it out at 18 panels represents, 2 guys for one day? That's a lot of man days. And then obviously there's admin people and finance people and procurement people that need to support those installers as well. So it's tough to put a number on how many people are actually employed in the industry, but I'm guessing it's pushing 30,000.
That's a lot. The COP26 conference was on this week, and they've committed to net zero. It's been pushed onto industry to come up with the outcomes, and ultimately that's going to be a good thing for us. I mean, we've been nursed by renewable energy certificates, STCs. Some have argued that the industry would have been better in the last 3 or 4 years without STCs.
Look, I don't think so. Upfront cost is a big deal, and we're still $40 an STC or $38 an STC. And with deeming periods in different states, how much of a representation of the cost of the system has that resulted in? It's probably around $3,000 for 6.6, yeah? Thereabouts. We're good with that number?
Yep.
Okay. So that's 45 cents a watt. So we've effectively got our panels paid for by somebody else, which is amazing.
So one of the other big things this week was Benny isolators are back on the ERAC database. So good to install without dispute, which is a good thing. And then the conversation changed online on solar cutters. So question marks come on some of the inbuilt DC isolators in the inverters. Do you think that's going to be a big issue, or would the manufacturers be across it?
We spoke to Rod earlier about compliance of the isolators, and he seems to think that certainly in the case of Fronius, it's different labs that have done it and therefore should be okay and not affected by the same thing that affected ZJ Benny. So watch this space. I guess that it's possible that that particular lab certified the isolators in the inverters, and given that the standard requires that they're tested in the inverter, not outside the inverter as in an isolator, It wasn't a case of installing a ZJ Benny isolator inside your inverter and you automatically got compliance and you got noted on the ERAC list. It needed to be noted as the inverter manufacturer, and then you took responsibility for what you put inside that inverter, whatever that might have been.
Right.
And then I guess it depends where you got that inverter certification done as to whether it may be affected by the same issue. You and I have taken isolators apart in the office personally. See how they're put together and compared a couple of different brands and how wide the contacts were and how many different contacts there were.
And they've got different alloys.
Very, very difficult by taking it apart. The only real way, of course, is to test the thing to destruction and see when it sets itself on fire. And there's different standards. And our other friend, Hippie Sparks in Queensland, was testing DC circuit breakers and certainly managed to set fire to a few, and he did a couple of videos on it, which were highly entertaining at the time. And it's great that there's people out there in the industry that are prepared to set up those kinds of tests and do what amounts to real-world testing connected to an array in full sun in the middle of the day and see what happens when you short-circuit it through these isolators.
When the new AS4777 rolls in a couple of months, the requirement for rooftop DC isolators disappears.
So while we're talking about that, Luke, my understanding is also that the 600 volt rule will disappear for domestic.
Yeah, apparently it's going up to 1,000 volts for domestic. It's going to be interesting. I think it may open up a whole range of new products from manufacturers that have been available in other markets with higher voltage limits, which is a good thing.
Yeah, look, I think the biggest thing for Australia and particularly for you over in WA is that to make an inverter, make a sine wave without doing any bucking or boosting, the magic number is 580 volts input on a three-phase and 360 volts input on a single-phase inverter. So 580 volts is a big number, and we haven't been able to get anywhere close to that with a 600-volt VOC limit. We're seeing running voltages much, much lower. So to get them up around that 580 mark and be able to do strings of, say, 20, 22 panels, particularly with the current ratings on the panels that we've got, realistically, we might be able to see 17 390-watt panels in a single string. And that simplifies everybody's job, simplifies BOSS, isolators, branch connectors, all of that sort of stuff just disappear. It gets a lot easier.
Absolutely.
I was going to say the other risk is when we had, say, 2 strings of 12 or 2 strings of 10 panels, someone connected them accidentally in an isolator as a short circuit, typically ended up with a very big spark. And if you don't have to have that paralleling of strings, that risk disappears.
And there's a trend in the roadmap of manufacturers towards larger cells as well. So in the news, there's a new Trina Vertex panel that's coming out at 670 watts, and they're using 210 mil cells, similar to some of the other ones we've seen where you've got high voltages in the panels. Potentially, the panels are going to get bigger. I mean, how big do you want them? Big as a football field? Some of the panels are pushing over 25 kilos, which looks good on paper and it looks good on a quote, but for an installer lifting them day-to-day up ladders, it's pretty tough.
Yeah, look, did that myself this week. I had a neighbour who recently got a job with Solar Edge, and they gave him a 10 kilowatt inverter and some optimizers to change out his Fronius so that he could familiarise himself with the product. And later they're going to give him a battery, apparently. There's some hardware shortages there at the moment, is my understanding. There's
That's a common theme.
Yeah, not available yet. But what I learnt was that even at 1.50 metre wide, doing up a mid-clamp is a hell of a stretch if you're really doing the right thing and not kneeling on a panel, standing on a panel, putting a hand on a panel. That's a long way to reach with one hand and a rattle gun, and it turns into a long day.
Yep. You got the job done.
We got the job done, yeah. He seemed to think it was going to take us 4 or 5 hours. It ended up taking us 4 or 5 hours times 3 days.
Okay.
I'm too old for this shit. Installing panels is a young man's game. And even if you're a licensed electrician and you don't know much about solar, it turns into a lot of on-the-job training with the standards that our industry is doing as a matter of course. Yep. 5 years ago, if someone said cable clips, plastic-coated stainless steel zip ties, you just got strange looks. Even conduit, when we started, wasn't a thing. It's truth. When we started, DC cable wasn't even a thing. We used to use normal TPS.
Yep.
Albeit 4 mil. But yeah, now we're spoilt with a great array of products. And of course, you and I got in touch with some people that we met at Intersolar, and we've now got a group set up in Brazil.
That's right.
Installers over there who are...
with Annabelle, who
Annabelle
used to be with Fronius, and now she's doing lots of amazing things throughout South America.
That's great that we can share some knowledge with those guys, and they really are 10 years behind us. So that they're only just starting to look at this stuff. And of course, we've got a massive industry with thousands of people employed. So they've got a steep learning curve, and I think they're going to do really well. It's great that they're embracing the renewables like we are and building an industry from nothing.
And as much as we complain about regulation and, the new requirements of taking 3 selfies on site and all the things that you've mentioned, a lot of it's actually a good thing from a safety perspective to make sure guys are doing the right thing.
We have had some great news in the supply chain this week. It looks like we are able to get good quantities of stock out of China. There's some shipping delays. We're hearing about from different manufacturers, seeing some of that. Dates pushed back.
So shipping delays, but there does seem to be stock coming into the country.
Yeah.
We've previously flagged potential issues due to production constraints in China. That is still there, but there seems to be enough product coming into the market at this stage to keep the wheels turning over. But one of the good signs out of China is that the price of wafers has come down in the last week. Maybe that's the first signs that pricing is stabilising. we've had a bit of a shock with pricing going up, but it seems that even though we've come up and it's been a drastic change, there seems to be a little bit of stabilising in our market as well now, and we'll see where it goes from there.
Well, another interesting one, a customer asked me today, what was the difference in demand for a 390 versus a 400?
Good question.
That meant that manufacturer was considering bringing that other watt class to Australia and how that would look in terms of their sales. And from where I sit, it looks a lot like fitting those specific numbers, 6.66, is really important to our market. And whilst there's the occasional job that doesn't apply to, having a panel that will fit that mould nicely.
It does matter where it is in the country too. Somewhere like WA where you have a strict 5 kilowatt inverter limit before you lose your REBs or DEBs or feed-in tariff, versus ones where you can go with the larger inverters and export limit. They're more receptive to the 400 watts, whereas the markets and the DNSPs who have strict 5 kilowatt limits, or there's some sort of limit for one reason or another, the 390 is a better panel for oversizing. I don't think it's a one size fits all. It does vary around the country. But ultimately, if you need a panel and panels are scarce in the market, you'll take either.
I agree. I don't know that we got to that point, though. I really don't think that we hit rock bottom there.
So we didn't hit the worst case scenario. There was potential that it was really going to be severe. There was potential it was just a blip, and we've ended up somewhere in the middle. One of the other things I'd like to talk about is COVID, as if we haven't enough, but we've seen some really good signs where Victoria, there's no longer restrictions on how many jobs that can be installed per week. Travel is opening up.
It was only 3. So I don't think that much of the country, particularly in WA, really understood how significant an impact that is. If you're going to a job a day, all of a sudden, you can literally only do 3 jobs a week instead of 5, perhaps 6, or, if you've got a 4-man team, you're doing 7 or 8 different sites in a week. And now you're down to just 3 sites. So that's a big boost for the capability in Victoria, absolutely.
And the travel as well, being able to have skilled solar industry workers travel around between the states.
Yep.
For projects,
look, particularly in those more specialised areas of the industry where you've got off-grid guys that they're few and far between. So I think we're have to be getting close to 8,000 CEC grid-connected certified Sparkies. And last I checked, there were only 88 off-grid guys in the country. So they're a special group, and as a result, they really do move around a lot more. And if you had a job going on in New South Wales, you could either get there and have to isolate for 2 weeks on your return. That was obviously problematic for a small job. You can't take yourself out of circulation for 2 weeks, so those jobs can happen. We were talking earlier about the changes to the inverter standard. So I'd like to introduce Rod Dewar. A man who needs no introduction in the solar industry. He's known by everybody who's anybody on various standard committees. And of course, he's a solutions manager at Fronius, which means he looks after most of our staff-ups.
Welcome, Rod.
How you going, guys?
Yeah, good. So one of the questions I have is around the new AS4777. So that's going to roll in a couple of months. Yep. And some of the advice we've been given to customers and around the country, and the CEC has been doing the same, is to check your stock, what you have in your warehouse, to confirm it's still going to be compliant after that time. And I think there's going to be some inverters that won't be compliant. So first of all, can you give us a bit of background on what the changes are that are coming in and why they're being brought in?
Yeah, for sure. So I think I personally think it's a good thing, the new updates to the standard. So the main driver behind the whole thing, and this is where it kind of got interesting with the committee, they were, the plan was to kind of update the standard, but the main driver was really AEMO driving through it, seeing the inverters dropping off the system when there are grid disturbances. So in the early days, it was always, when there was very little PV and very little inverters, they made up a pretty small percentage of the overall generation and grid supply. it was if the grid was out of spec, voltage or frequency, then let's disconnect ASAP kind of thing and get off the network. That was fine when you had 1-2% worth of part of the grid and energy production. But now we're getting up to decent sizes. It's becoming a big, one of the biggest generators on the grid. And so what they're saying is that if you have a grid disturbance, especially obviously on the high voltage line, et cetera, that ripples down, and you get things like frequency jumps, phase jumps, big voltage dips, et cetera. And when that happens, basically, if you kick off a whole bunch of inverters, having 1 or 2% wasn't an issue, but when you start getting to like 20% of the overall production, that's a massive part of generation that drops off. Basically, the idea is they want the inverters to hang on as long as possible. So when there's grid disturbance, it's often not just an on-off. You'll notice when you have a blackout or a brownout or something, you'll see the lights flicker kind of thing, and they'll stay on, or sometimes they'll go completely off. But often they'll kind of flicker a bit and stay on. And when you look at the voltages on the grid, that's where they jump around. And what they want to do with this new standard is basically get the inverters to be able to hang on as long as possible. If it's conks right out the grid, then obviously jump off. But for most of those disturbances, it's all about riding through that. And so there was quite a few different changes put in the standard. There's quite a lot of things which are kind of already in inverters now already, like your volt var and volt watt, et cetera. So they've kind of got cleaned up in terms of the values that should be set and defaults and all that stuff. That was all pretty straightforward. But the biggest change was really the ride-through capabilities of inverters. And so it's a much more rigorous test in there. And there's, depending on what voltage range and what timing is happening with the grid disturbance, then the inverter needs to what they call cease power generation, which means doesn't disconnect from the grid, but just goes to 0 watts and sits there ready, waiting to ramp up again. And once so if you have like a grid disturbance, it has to cease power generation within 200 milliseconds, so pretty quick, so like 10 cycles. And then once the disturbance is gone and the grid comes back to normal, then within 400 milliseconds, it has to go back to its original operation that it was doing. So that's a pretty rigorous test to do. Some hardware can take it. If any of the inverters that are used in the US, they have similar kind of requirements around that. They're actually a bit more stringent. So if you're
hard to achieve as a manufacturer?
Well, it depends on the inverter topology, et cetera. So for example, for Fronius, our Galvos, they're a transformer-based inverter. They have a certain kind of switching mechanism on the input. And so because of that, they're not capable of doing that ride through. And hence that's why we're not relisting them. And the Cyma Hybrid is the other one we're not relisting, but that's more because of upgrading to the Gen 24s on that. But it is a bit of a challenge for the inverters to do that in terms of a bit of hardware, then also the software and the control, so the power module control, etc. So that's probably one of the major ones. And the other major one is, as I said, voltage phase angle shift, like a phase angle jump. So especially when you have on the high voltage line, the phase to phase fault, then the 120 degrees out of phase. And so if you join them together, then depending on what phase collapses, you'll have this massive phase jump between them. And that ripples down through to the low voltage side as well. So you can have that on low voltage connections. And so the inverter needs to be able to ride through certain phase angle jumps, that's probably the more full on test. So an inverter needs to be able to detect when the grid's not there, so anti-islanding. So it needs to be nice and sensitive for that. But then you've got to get the balance between that and then also withstanding like a phase angle jump, which is pretty full on for an inverter, because you've got this synchronized PLL phase lock loop type control of inverter that's looking at the voltage and the current and trying to synchronize to that. And then that thing that it's synchronizing to, you're throwing it all around, and it needs to decide, okay, do I stay on or do I disconnect? So that's what makes it pretty full on, yeah.
So before we started this conversation, we were talking about the grid operators and ultimately AEMO dictating that we need smarter inverters on the grid and solutions that are capable of dynamic export limiting and remote shutdown and that sort of thing. But you think about the critical mass that's already on the grid that isn't a smart solution, can't be switched, can't be controlled. And you can see why ideally it should have come in years ago, do you think?
Yeah. So, I mean, especially in WA, I mean, it's essentially a big islanded grid. That's even more essential, I would say. I mean, it's a tricky thing, getting this some of this stuff through. I mean, it's expensive and time-consuming for manufacturers to do all this stuff. So it's not an easy thing. I mean, you can see there's a 12-month transition period for the standard to get it, all the software, potential hardware changes implemented, get all that tested, working properly, get it in the labs, which are, test labs around the world are not just sitting there twiddling their thumbs waiting for jobs to come in. They're packed chockers until usually 6 months in advance. So you need to, get you in testing it, and then you've got to get all the certification, listing, etc. So even 12 months is very tight, as you'll probably see from, how many inverter manufacturers are already on the list at the moment. So it's a tough thing.
I'll jump in there with a simple stat. So there's typically only 2,000 working man hours in a year for a technical person. By the time you take some holidays, you have some sick days, weekends, all of those sorts of things, there's actually not a lot of time in a year. So I can see how it's been a big crunch. And the crunch from many of the wholesalers in the market is we didn't actually know from the manufacturers what was likely to be able to be relisted and what wasn't. So because these inverters needed to be physically tested, and a manufacturer might have thought that it was going to comply and we'll put it through the testing, and then all of a sudden, actually, this isn't going to work. We're not going to be able to get it to work.
So it's a good time for people to go through their existing inventory. If it's not listed past mid-December, they need to be speaking to the manufacturers or the wholesalers, distributors, wherever they get their product, and making sure it can be installed after that time. And just quickly, Rod, what's on the tech horizon for Fronius?
So at the moment, obviously, we've released the Gen 24 series, so that's kind of getting complete. So the 3-phase, the smaller ones, the 3 to 5s, and you've got the 6 to 10s. The single phase, you've got the 3 to 6. And we're looking at bringing out the larger single phase ones as well. So that's kind of on the horizon for us. And then the Toro, which hasn't been released yet, is getting its first certification. So that'll be coming to the market. So in the commercial range, you're 50 and 100. So it should be good.
And also involved in the hydrogen space. I've seen the hydrogen hub in Austria. Maybe not ready for commercialization.
Yeah, not for me. I don't know
pushing the frontiers.
I don't know so much about it personally on that one, but Fronius has been doing hydrogen for a good 10, 12 years now, looking into it. So it could be something on there, but not really up with that. Too much other stuff looking at the moment. So
Carl was talking about 2,000 man hours. You're at about 4,000, 5,000, I'm guessing.
At least feeling like that. Yeah.
Interestingly, there on the inverter roadmap, Rod, there is a surprising amount of inquiry to be able to couple multiple Gen 24s together to have larger backup capacity, particularly in the big 3-phase, 10 kilowatt 3-phase inverters. We're getting that question more and more. So I guess we're crossing fingers that Switched In might be able to come up with some kind of a solution, or there might be some kind of thing there on the horizon, or even we may see inverter manufacturers come up with much larger inverters that are capable of supporting batteries as well.
Yeah, so for us, it's something we're looking at the moment. Switched In obviously helps with the whole configuration of the multiple batteries, multiple inverters in terms of self-consumption, but also peak shaving, which is a kind of more of a big deal in Queensland, becoming more, and a couple of other functionalities, the export limiting, etc., across multiple buildings if you need to. That'll be also with the especially in commercial stuff. Let's say you have a distributed network, you've got 4 or 5 buildings, each one with 20, 30 kilowatts on it or something. But you need to export limit the whole site, then that's where that can really come into play. You can get a whole export limit for that whole site, all networked with Ethernet or networking IP IP control. So
is that stuff fast enough to deal with these changes to 4777 as well, or that's a totally different basket of issues? As in, if we're export limiting multiple inverters on one site, they're all ramping up and down evenly, or some buildings got more load. Does any of this stuff matter?
No, not really. No, I mean, especially for 4777, they're pretty lenient with the export limiting stuff. Like the timing on the export limiting is pretty wide, actually. Like it's pretty slow. They give you 15 seconds to respond, so which is pretty long in inverter time, really. So that's pretty easy with that stuff.
That's great news at last. So some good news. Hey, fantastic.
And Rod, the borders are opening up again. Does that mean that you're going to be jumping on planes again in the near future, or are you going to stay put in Vic?
No, I hope so. Yeah, no, really looking forward to getting out and about again and seeing people in person and having meetings and catch-ups and things. And, as you know, WA was one of the states I was often in and really enjoyed getting to. So, I just literally saw on the news this morning or today, the Western Australian Premier, I think it was, has made some announcements that he's no official dates, but setting a pretty high bar. Once you get 90% double dosing, double vaccine, they'll open the borders, and they say it's probably around the January, February mark or something like that. So fingers crossed.
At least there's a roadmap there, and into solar 2022 is still a possibility.
Oh, I hope so, yeah.
Hope so too. All right, Rod, well, thanks for coming on.
No worries. Thanks, guys, for the invite.
Thanks for your wisdom, and appreciate your time.
You're our first special guest. So should be presenting you with some kind of a medal. This is the highlight of the evening, and I'll throw in there that it is 9:20 on a Friday, and we really appreciate your time, mate. You know, you're obviously a huge asset to the whole industry, and we thank you a lot.
Absolutely.
No worries, guys. Thanks a lot. All right.
Thanks, man.
See ya. Bye.